There are high chances that you've spent a significant amount of your time in a Faraday cage at some point in your life. You might even have one in your house. First invented in 1836 by venerable English scientist Michael Faraday, they have become ubiquitous in our modern technological world. From keeping you safe in the air to keeping state secrets, they are simple yet very powerful tools. In this video, we'll take a quick look at just what they are and have a look at how they actually work. A Faraday cage, sometimes known as a Faraday shield, is an enclosure that is used to shield things from electromagnetic fields, both static and non-static. They are named after their inventor, the English scientist Michael Faraday, who devised them in 1836. Static electricity is that where the charges are at rest, hence the name. They, in effect, accumulate on the surface of a particular insulator. Non-static or current electricity is where electrons are moving within a conductor. Faraday cages are able to protect their contents, or indeed occupants, from feeling the effects of both. They can be made from a continuous covering of conductive material or from a fine mesh of conductive material. Static charges, or even certain types of electromagnetic radiation, and distribute them around the exterior of the cage. Put simply, Faraday cages distribute electrostatic charge around their exterior. They, therefore, act as a shield to anything within them. They are, in this respect, a form of hollow conductor whereby the electromagnetic charge remains on the external surface of the cage only. But in reality, like many things, it is a little more complicated than that. Regardless of their exact appearance, all Faraday cages take electrostatic charges, or even certain types of electromagnetic radiation, and distribute them around the exterior of the cage. Put simply, Faraday cages distribute electrostatic charge around their exterior. They, therefore, act as a shield to anything within them. They are, in this respect, a form of hollow conductor whereby the electromagnetic charge remains on the external surface of the cage only. But in reality, like many things, it is a little more complicated than that. The process called electrostatic induction creates an opposing electrical field to that of the external object. This process effectively cancels out the external electrical field throughout the entire cage. It is this phenomenon that insulates the cage's interior from the external electrical field. As you can imagine, these cages are pretty handy in a variety of applications. It is likely you've been in one very recently indeed. The most famous examples are automobiles and airplanes. Both in aircrafts and cars, fuselages act as Faraday cages for their occupants. Whilst less of an issue for cars, in the air lighting strikes are quite a common occurrence. Thanks to the plane's aluminum exterior, when this does occur, both the plane's delicate avionics and priceless passengers are left completely unscathed. Incredibly fittingly, MRI scanning rooms are effectively imitations of Faraday's famous 1836 experiment. They need to be built like this to prevent external radio frequency signals from being added to the data from the MRI machine. Microwave ovens are another notable example of everyday uses of Faraday cages. However, unlike other applications, they are designed to work in reverse and keep the microwave radiation within the oven. You can actually see part of the cage on the microwave oven's transparent window. Many buildings are also accidental Faraday cages, as it turns out. Large use of metal rebar or wire mesh can wreak havoc with wireless internet networks and cell phone signals. Another interesting application of Faraday cages is used by the military and other organizations. Faraday cages are often used to protect vital IT and other electrical equipment from EMP attacks and lightning strikes.